So for my part now, I'm going to present about the Fcfs definition. The Fcfs is an operating system scheduling algorithm that automatically execute the query requires and also the process by other of the arrival. It supports non-preemptive and preemptive scheduling algorithm. The FCFC stands for first come first serve. It's a real-life example of the FCFC method, which is buying a movie ticket on the ticket counter, and it is the simplest form of a CPU scheduling algorithm. It is a non-preemptive CPU scheduling algorithm, so after the process has been allocated to the CPU, it will never release the CPU until it finishes executing. And that's all from the definition of the FCFC.
So we are going to describe about the process and the best time of the first come first serve. Alright. Consider that the following set of process that arrive at time 0, which is 0 millisecond, right? So this is a process P1, P2, P3, and this is the burst time in millisecond. So P1 have the burst time of 7 millisecond, P2 have the burst time of 2 millisecond, and P3 has the burst time of 5 millisecond. Okay. So let's say the process arrived in the order of P1, P2, and P3, and we have to show it in a Gantt chart. So this is the Gantt chart, kind of. Alright, so since P1, P2, P3 arrive in order, like P1, P2, and P3, so we have to do P1 first. Since P1 have the burst time of 7 seconds, so 0 until 7 seconds will be P1. And then after 7 seconds, P2 will start for 2 milliseconds and will end at 9 milliseconds. P3 will start at 9 milliseconds and end at 14 milliseconds because burst time is 5 milliseconds. So what is the average? What is the waiting time for P1? Waiting time for P1 is 0 millisecond, while waiting time for P2 is 7 millisecond, and waiting time for P3 is 9 millisecond. So what is the average time for all three? So all we have to do is to add the waiting time P1, P2, P3. We add it up and divide by 3 because we have 3 processors. So the answer will be 5.33 milliseconds. Okay, so just now we already see what if the first come first serve for process P1, P2, and P3. So what if the process arrive were not according P1, P2, P3? What if they arrive P2, P3, and P1? As you can see right here, right? If the process arrive in the order of P2, P3, and P1, as you can see, the Gantt chart are a little bit different from the beginning. And so, what's the waiting time for P1 if it is out of order? So for P1, the waiting time is 7 ms because on P2 started on 0 ms and it has 2 milliseconds of time burst, and then it started after 2 milliseconds. P3 started, which is consists of 5 time bursts, and ended at 7 milliseconds. So that is why P1 started at 7 milliseconds. What is the waiting time for P2? Since P2 is the first thing ordered, the first thing arrived, so the waiting time is 0 millisecond. What is the P3 again? What is the P3 waiting time? Since P2 consists of 2 millisecond time bursts, so that is where P3 starts. And what is the average waiting time? So all three of this, 7 milliseconds, 0 millisecond, and also 2 milliseconds, added up, divided by 3, and we got the answer.
What is shortest job first scheduling? Shortest job first, or SJF, is an algorithm in which the process having the smallest execution time is chosen for the next execution. This scheduling method can be preemptive and non-preemptive. It significantly reduces the average waiting time for other processes awaiting execution. The full form of SJF is shortest job first. There are basically two types of SJF methods: non-preemptive SJF and preemptive SJF. In this operating system tutorial, you will learn what is shortest job first scheduling, characteristic of SJF scheduling, non-preemptive SJF, preemptive SJF, and advantage of SJF, disadvantage or the cons of SJF, characteristic of SJF scheduling. It is associated with each job as a unit of time to complete. This algorithm method is helpful for batch type processing, where waiting for a job to complete is not critical. It can improve process throughput by making sure that shorter jobs are executed first, hence possibly have a short turnaround time. It improves job output by offering shorter jobs which should be executed first, which mostly have a shorter turnaround time. SJF is an algorithm in which the process having the smallest execution time is chosen for the next execution. SJF scheduling is associated with each job as a unit of time to complete. This algorithm method is helpful for batch type processing, where waiting for job to complete is not critical. There are basically two types of SJF method. Number one is non-preemptive and number two is preemptive SJF. In non-preemptive scheduling, once the CPU cycle is allocated to process, the process holds it till it reaches a waiting state or terminated. In preemptive SJF scheduling, jobs are put into ready queue as they come. Although a process with short burst time begins, the current process is removed or preemptive from execution, and the job which is shorter is executed first. SJF is frequently used for long-term scheduling. It reduces the average waiting time over FIFO, first in first out algorithm. In SJF scheduling, job completion time must be unknown earlier, but it is hard to predict. SJF can be implemented for CPU scheduling for the short term. It is because there is no specific method to predict the length of the upcoming CPU burst.
So moving on short job first, right? So for example, this is how the process and the burst time. For example, let's say, so P1 have the burst time of 7 milliseconds, P2 have the burst time of 2 milliseconds, P3 have the burst time of 5 milliseconds. So this is how the Gantt chart would look like, right? Okay, so since short job first have to go first, executed first, doesn't matter if P1 or P2 or P3 arrive first, the shortest job have to go first. Since P2 has the shortest burst time, that is why P2 has to go first. And then the second shortest is 5 milliseconds, which is in P3, process 3. And the third one is P1 because the burst time is 7 milliseconds. So what is the waiting time for P1? Since P1 here, and the waiting time will be 7 because P2 executed first and have the burst time of 2 milliseconds. Then added up by P3, which has the burst time of 5 milliseconds, and that is why P1 started at 7 milliseconds. So what is P2? Waiting time. P2 is the first one because it was shortest one, so the waiting time is 0 milliseconds. So what is the waiting time for P3? Since P3 has the second shortest job first. So P3 has 5 milliseconds, so it's B second. So it's going to be started at 2 milliseconds. 2 milliseconds. So what is the average waiting time for all three of them? So 7 milliseconds plus 0 millisecond plus 2 milliseconds divided by 3, because we have 3 processes involved. So the answer is 3 milliseconds. So just now you already see a non-primitive short job first. Now moving on to primitive short job first. In primitive short job first scheduling, jobs are put into a ready queue as they come. A process with the shortest burst time begin execution. If a process with even shorter burst time arrive, the current process is removed or preempted from execution, and the shorter job is allocated CPU cycle. Okay, so consider this is the 5 process, right? We have process queue, burst time, and arrival time. As you can see, P1 has the burst time of 6 and arrival time of 2 milliseconds. P2 have the burst time of 2 and arrival time of 5. P3 have the burst time of 8 and the arrival time of 1. P4 have the burst time of 3 and 0 arrival time. And P5 has the burst time of 4 and 4 arrival time. So first thing first, at time 0, P4 arrive and it will start execution. So since at time 1, process P will arrive, but P4 has a shorter burst time, it will continue execution, because P3 at time 1, right? P3 has the burst time of 8, so P4 will continue, as P4 is the shortest burst time. So next would be at time 2, right? Process P1 arrive with burst time of 6 milliseconds. The burst time is more longer than before. Hence, P4 will continue execution, because burst time of 6 is larger than 4. So next, at time of 3, process 4 will finish execution. The burst time of 3 and P1 is compared. Process P1 is executed because its burst time is lower. So at time 4, process P5 will arrive, right? So process P5 will arrive. The burst time of P3, P5, and P1 is compared. Process 5 is executed because the burst time is lowest. P1 is preempted. So as you can see here, process queue of P1 of the burst time 5 out of 6 is remaining, and on the P5 3 out of 4 is remaining. So at time 6, P2 is executing. So in total there will be P4 first, P1, P5, then P2. So at time 7, P2 finishes it executing. The burst time of P1, P3, and P5 is compared. Process P5 is executed because its burst time is lesser, right? So at time 10, P5 will finish its execution. The burst time of P1 and P3 is compared. Process P1 is executed because its burst time is less. So at time of 15, P1 finishes its execution. P3 is the only process left. It will start execution. Then at time 23, P3 finishes the execution. So what is the waiting time of P1? So as you see, P1 has 3 milliseconds minus 2. Then we have to add it by 6, which equal to 7, right? Then for P2, it has 0 milliseconds, because 5 minus 5 is equal 0, am I right? Then the P3 is 15 minus 1, which equal to 14. And let's say P4 is 0. It's where it was started. Right. So what is the average time of the waiting time? So we have to add it all, divided by 5, and the answer is 4.6 milliseconds. Thank you.